Hey guys, Mr. Middleton here, going over the overlapping triangles notes. Okay, we've gone through a lot of different proofs, congruency proofs, talking about CPCTC, isosceles triangles. So we're not really learning new things, I guess, as much as we're learning how to look at new situations, okay, and seeing how what we know fits in there. So by the end of these notes, you should be able to identify shared sides and angles and overlapping triangles. You should be able to redraw and label two triangles from overlapping triangles, and then you should be able to prove two overlapping triangles are congruent. So that's our goal for these notes. So let's jump into it. Alright, so notice how in each of the diagrams below there is at least one common part between the two triangles. Okay, common, meaning shared, or you can say shared if you'd like. Okay. So if you look at number one, we have this triangle, or not really triangle, it's more like a Star Trek thing. Yes, Trek, not Wars. Okay. So if you look, I can see triangle ACB and triangle PRB. Okay, do you see those two triangles? Okay, so I can see those two. What's the shared part? What's in both triangles? Well, the thing that's in both triangles is B, this angle. Okay, this angle B. It's an ACB, and I'll just dash it because I have this color. Okay, it's also in PRB. See that? And that's the only part that's shared between both of them. Okay, so angle B, shared between both of them. Okay, here, what's shared in this figure? Well, I can see this side, LP. Okay, LP is shared in both sides, or in both triangles. Maybe a little bit more difficult here what we're looking at, but it's kind of the same thing as number one, except now we have the bottom drawn in it. So where number one was open on the bottom, this one the bottom's not open, but we still have that angle D. So in triangle ACD and BD, we still have that angle D is shared part. Okay. Alright, anything else shared there between those two triangles? Alright, so that's our shared parts. Now that will help us out because we've done this a lot, especially with problems where we have, let's say, triangles like this, where we have a shared side. We use that shared side to help us prove congruency, and a lot of times using the reflexive property of equality. And so we can kind of do the same thing here. If we had proved these two triangles are congruent, no doubt that I'd use LP is congruent to LP as one of my statements. Okay, so those shared parts help us out. Alright, when you've identified the shared parts, you have one congruent part of the two triangles because of the reflexive property. That's what I just said. Okay. Then you only need two more congruent parts. Remember, because for everything, even the HL theorem, we need to have three things. You know, either two angles on a side, or three sides, or two sides of an angle, in order to prove that our triangles are congruent. So, identifying that shared part gets one of those things out of the way. All right, let's look at this flow proof. Difficulty level 4. Remember, that's kind of I don't know, I forgot the word. Arbitrary. There you go. It's kind of arbitrary difficulty level. It depends on what you're used to seeing, but this is probably the middle of the road proof. Let's look at what we know. So they tell us that angle T is congruent to angle R. They tell us that PQ is congruent to PV. And they want us to prove that angle PQT is congruent to angle PVR. Okay, anytime I'm seeing this, it's not triangle, it's angle. That perks my ears. CPC, TC. Make me think, hey, I probably have to use CPC, TC because I'm not proving two triangles congruent. I'm proving two parts of triangles are congruent. Alright, so let's see what we start with. Usually I like to go out and like really set up what we're doing, but they've already got most of our reasons, so I should follow along with them and just kind of think about what they've said. So angle T is congruent to angle R. That's given. That's the reason. And I'll just make sure they have that marked for us. Angle T is congruent to angle R. Okay. Angle TPQ is congruent to angle RPV. TPQ, RPV. As you draw over these angles, TPQ, RPV, you can see that. Alright, so I marked that out. Now, the kind of confusing thing about this is as I see what triangles they're talking about now, I can kind of point it out. I've only made one marking. It might be helpful for me to kind of separate those triangles that we're referring to, just so I can double check when I'm done that I have everything that I need. I have T, P, Q. Okay, and it doesn't have to be exactly the same. The important part really is that I'm able to refer to the sides and the angles that I need to. Okay, this is R, P, V. Okay, so I'm just going to make sure I have those same markings. P, R. Okay. Alright, so that's what I have. We can say that these are equal to each other in this picture. This having both these pictures helps because this is the same angle. It's a shared part. Okay, so we don't say because of the shared part. It's actually the reflexive property of equality. Reflexive property of equality if I had more space. Okay. Then they say that PQ is congruent to PV. Well, that's also a given statement. Given. Okay. PQ and PV. Okay, and that's exactly why we want to separate it, because it's kind of hard to see, like, oh, what are they talking about when they're overlapping. But as we separate it, PQ, PV, is that what they said? Okay, cool. Alright, so we have everything. And now they say triangle TPQ is congruent to triangle RPV. Well, why is that? We have angle, angle, side. Side, angle, angle. Okay, doesn't matter what order we have these in. Alright, I'm just going to circle these so you know they're not points. Alright, so we have two angles and a side. So this is either angle, side, angle, or angle, angle, side. Okay. Now, I know that it's angle, angle, side because the side's not in between the two angles. Okay, it's not included. So now I've proved that those two triangles are congruent. And now that I've done that, I can say, hey, angle PQT and angle PVR have to be congruent. They have to be congruent because they're corresponding parts of congruent triangles. So, CPC, TC. Okay. Again, we did this already. It can be confusing to answer D. This D. Okay. It can be confusing to answer D, so it might be a good idea to redraw the triangles. Okay, there's so many markings, it's all on top of each other. Sometimes redrawing those triangles helps you see it a little bit easier. I forgot to move this. Sorry. Alright, flip to the back. Alright, so when we see overlapping triangles, we might be put ourselves in an advantage by redrawing and labeling our new triangles. Okay, redrawing and labeling our triangles. So not just redrawing them, but labeling them so that when we refer to and have congruent spots, we can mark them accurately. So we got some space to do that up here. TPQ, oh, that's TPQ and RPV. We did that on the front side. We did that on the front side. We won't do it back here. You can redraw and label it back here if you need more space. Okay. We'll do some more redrawing and relabeling here with these other three proofs. So, our first overlapping problem proof, they have triangle QDA and triangle UAD. They want us to prove that they're congruent. Okay, so that kind of gives me an idea right there, like, hey, those are important triangles. Maybe I should redraw them. I'm going to use this space up here, just so I can have some more space. Usually I don't need to have them this big, but especially because we're going through our notes, might be a good idea. Again, if I don't have them the same size and the same shape, that's okay. These are just reference points. They're not really here to be anything more than that. Okay. Alright. And then as I'm going, I'll just make sure I have the markings done. So, again, they didn't give us givens here, but they did give us given information in our diagram. So let's use that. First given information that I noticed is they told me that UA was congruent to QD. Okay, and that was given. Okay, and I'm going to make sure I mark that. It's marked here, UA and QD. I'm going to mark it on mine as well, UA and QD. Alright, another piece of information that they gave me that angle QDA was congruent to angle UAD. Okay. Again, that's given information. I'm going to make sure I mark it here. UAD, QDA, marked congruent. Okay, so now, what do I see that can help me out? Because I need to prove that these two triangles are the same. Well, especially in my overlapping triangles pictures, I can see that DA is a shared side. So yeah, DA should be congruent to DA. Why? That's the reflexive property. Okay, and I'll definitely mark that. Okay, I can even mark it here if that helps me out. Okay, and so now looking here, I have side, angle, side. Circle those so you know those aren't points. Side, angle, side. Okay. And so I have my angle included in between the two sides, so that it definitely is side, angle, side. And I can say, and have proved now, that triangle QDA is congruent to triangle UAD. Okay. So not too difficult, not terribly difficult there, but separating those triangles did definitely help us to see what was happening a little bit better. A little bit better. So let's go down to let's do this one. Second one. Get that arrow off the screen. Alright. So they gave us some information. This time they're giving it to us in a given statement, not just on the diagram, so we have to make sure that we draw it ourselves. They want us to prove that ED is congruent to CD. Again, this perks my ears. This makes me think, hey, they're not asking me to prove two triangles congruent. It might lead up to CPCTC, okay, where I have to prove that because our triangles are congruent, the corresponding parts are congruent. So, I want to know what's important. They're asking me about ED and CA. Or sorry, ED and CD. Kind of have a leaning that they're asking me about these two triangles. I'm going to mark my givens and then make sure. They told me that EB was congruent to CA. Man, that's hard to mark. EB, CA, okay. And they told me that DAC, this angle, was congruent to DBE, this angle. Alright, cool. They're definitely talking about triangle BED and triangle ACD. So I'm going to draw those triangles out because this overlapping stuff, I can barely know what I'm talking about if I stop thinking about it for too long. So I'm going to draw these separately, A, C, D. I got another one here. Okay, B, E, D. Okay, so I got those two triangles there. Redrawn. I'm going to remark this thing that told me that EB was congruent to CA. Mark that. Okay, they told me that that angle DAC was congruent to the angle DBE. I'm going to mark that. Okay, got those done. Okay, so I have this information here. It looks a lot better here than it did here. Alright, what else can I find out? Okay, this is where the shared picture helps us. Look, this angle D. Kind of looked at it already on the front, problem like this. This angle D is here. We can tell it's the same because of the reflexive property. So I'm going to mark that. My information, I have angle, side. Okay, I have that here, angle, side. Okay, so that's what I have on both of them. I could prove that these two triangles are congruent by angle, side. Let me look at ED and CD. Definitely look corresponding. I go from 1, 2, B, D, E, A, D, C. Yep, they are corresponding parts. So now I've kind of walked through what my reasons are. Writing this proof should be a lot. Oops. Wow. Hopefully that wasn't there the whole time. Okay, so I walked through what my reasons are. Writing this proof should be a lot easier since I've marked all this stuff already separately. Alright, so let me start. I'll start with my givens. EB is congruent to CA. I know that because they told me, or it was given to me. Number 2, I have that angle DAC is congruent to angle DBE. That also was given to me. Something else I said that angle, I'll call it angle ADC, was congruent to angle BDE. Okay, it was a shared part, so that's the reflexive property. Okay, and so with all that marked, now I can say, hey, these two triangles, triangle ADC is congruent to triangle BDE because of angle, side. Okay, now with those things congruent then, I can say, hey, CD, DE, they're corresponding parts. So CD is congruent to DE by CPCTC. Alright. And so now I've proven that.